So in this series of learning programming in C, we are discussing some programs on matrix. In the previous video, we have discussed the theory of this program, how to do matrix multiplication, like how to multiply two matrix, how the logic behind multiplication, the rules and the conditions, everything we have discussed in the previous video. In this video, we will write a program. First of all, I will write a program here, we will write in that program step by step, and then I will show you output on my laptop. Practically, you will also see, right? So now I am taking these two matrices. We will be reading these matrices first and then we will print the final matrix. So the dimension would be, size would be number of rows of first matrix, number of columns of second matrix. So that would be 3 into 2 matrix, that is for sure, right? Can we multiply this? Check. Columns of first matrix 3 should be equal to number of rows of second matrix. Number of rows 3, yes, equal, yes, we can multiply these. So I am just writing down the logic here just for multiplication. For reading purpose, like nested loops and scanf, I guess you can do, we have read matrix multiple times. So that I will show you directly on my laptop. Right. Here I will just discuss the code to multiply these matrices. Right. I am assuming that you have written the code to read these two matrices and to print these two matrices on the screen. Right. Now see the logic here. I is 0, see second, this matrix, resultant matrix is suppose C, this is A, this is B. So dimension for C is 3 into 2, means number of rows 3, 2, number of columns. So outer loop would be for number of rows, we know, so that would be from 0 to 3. Inner loop would be for number of columns, so that should run from 0 to 2, because here we will be having 2 columns. So J plus plus, right? Now here, what logic we have to implement? See, index is 0, 1, 2, 0, 1, 2, 0, 1, 2. Please try to understand this one clearly first of all here. If you get this logic, you can easily write down the program at your own. So first we will take this complete, multiply with this column. First column of, column 0 of second matrix, row 0 first matrix, and we will access this and add this and this and add, multiply this and add, and whatever the value we will get, we will store here. The sum we will store here, right? So now how you are getting? See, here I am multiplying what? I am accessing and multiplying what? A of, I am accessing these elements, means index would be 0, 0, 0, 1, 0, 2, means first index is 0, right, and that is I. For first iteration I would be 0 for all the iterations, then it would be 1, right. So we are accessing this row. So for this entire row I value is 0, because row, for handling row we are taking a variable I. This loop is for row, right. So A of I. Now second subscript would be what? I am accessing second subscript is changing every time, 0, 1 and 2. First time 0, then 1, then 2, right. But we cannot write down here J, because J would always be run from 0 and 1, 2 times only. Once J becomes 2, out from the loop, and I want this value 0, 1 and 2, and we cannot write I here, because obviously we have written I here, we cannot write J. So now what you will write? We have only two variables I and J, so here we will take another variable K, and that value would run from 0, 1, 2, right. Now into B of, here in 2 subscript, what you will write? We are accessing this one, right. So index would be 0, 1 for this, 1, 0, 2, 0, means the second index is same, that is 0 every time, right. And if you will access this one, the second index would be 1 every time, 0 and 1. We are not having any other column, we are having only 2 columns, 0 and 1. So here we will write directly J. 0 and 1, J would run from 2 times 0 and 1. So here you will write J, but here what you will write? because it's changing 0 0 1 0 2 0. So here we will write k. Obviously we cannot write I here because I value is what, for every iteration it's 0 and this value is changing 0 1 2. We are simultaneously accessing this and this, then multiply this and this, multiply this and this, multiply and then add also. So we are going to multiply this, right, and also we are going to add in this one. So we have to take another variable k and we will add in this, we will take another variable like sum, and whatever the value here we are going to store that into sum again, right. So before this another for loop, that is k should be 0. Now upper bound of k would be what? It is basically for the multiplication purpose, right. So k would run 3 times, 1 2 3, and here also k is handling this or this 3 times. So 0 to 2 it should run 3 times. So k less than 3. Or here what you can write, upper bound must be either number of columns of first matrix or number of rows of second matrix. Here both are 3 and 3. So that is why it is 3 and k plus plus. And this you have to write down, this line you will write down in this loop, okay. And whatever the value in sum, obviously we are going to store that value in this matrix sum. So at C of ij here we will store sum, fine, that's it, right. Now for again what we will do, this row but now this column, right. So sum you have to initialize again with 0, otherwise it will take whatever the value in sum and it will add in that sum value this and this. So whatever you will get here, that should not be correct. So after this loop again we will initialize sum with 0. So where we should initialize the sum 0? Outside of this for loop. So here we will initialize sum is equal to 0. Within this j loop, sum is equal to 0 we can initialize here, and before initializing obviously we will declare this variable after main function, like wherever we declare this ijk variable, there only we can declare this sum, right. So it's okay, we have stored here, right. Now we can close this for loop and then this I loop. And now if you want to print this C matrix, nested 2 loops would be required. I would be 0 to 3, j would be 0 to 2, and directly you can print what? Printf %d C of ij. That's it. That is very simple. Here the main logic is this loop, the kth loop, and what you will write here, that is very important. That's it. Otherwise there is nothing in this multiplication program. So let me dry run this logic and then you will get it, right. See, we have I variable, we have j variable, as well as we have k, and also we have sum, right. So I is 0, condition true, enter, j is 0, condition true, enter. Now sum would be initialized with 0 here. Now here we have one for loop k would be initialized with 0, condition true, enter. Now see the statement, sum is equal to sum plus this, sum is what? 0 plus. Now what we are accessing, I value 0, k value 0, I value 0. So a of 0 0 means 0, b of 0 0 means 1. We are multiplying 0 into 1, that is 0, right. So 0 plus, here we have again the value is 0, and whatever the value, that would be what? Stored in this sum. So now sum is still 0, right. So now we haven't got the exact output whatever we want here, because obviously we want to add this and this, multiplication of this and this and this and this. So now rather than storing sum here, better to store this in this kth loop. We will only write this one line, sum is equal to this, and after closing this k loop, then we will store the sum into C of ij, right. So now see, now the working is what? See, we have done this, sum is equal to, sum is still 0, now k plus plus, now k becomes 1, Condition true, yes, again enter here 0, 1, 1, 0. So now sum is equal to sum, whatever value in sum, still we have 0. 0 plus a of 0, 1 we are going to access. A of 0, 1. A of 0, 0, 1, that is 5. So 5 into B of 1, 0. B of 1 and 0, that is 0. So that is what? 0. Right? 5 into 0, 0, and sum is also 0. So now still sum is 0. Again k plus plus, k becomes 2. Yes, condition true, again enter here. Now we will access 0, 2 and 2, 0. So sum is still 0 plus 0, 2. A of 0 and 2, this one. 2 into B of 2, 0. B of 2, 0, that is 3. 3 into 2, 6. Now that would be stored in sum. So sum becomes now 6. Now k becomes 3. Condition true? No, condition is not true. Exit from this kth loop, and now we will store this at C of ij. I value is 0, k value is 0. Sum is 6. So we will store this at 0, 0. So here we will store this 6. So first element we have got of the resultant matrix, that is 6. Right, and I hope it's correct. Fine. Now see, after this line, what? Now still we are in this jth loop. So now what will be done? J plus plus. Now j becomes 1. Now condition true, again enter here. Again sum would be initialized with 0. Right? If you will not initialize the sum with 0, then by default what? The value in sum is 6. So it will take 6 plus it will do what? Multiplication of this, and it will store here. So that would not be correct. So now again we have to initialize sum with 0. I hope you are getting my point. Right? Now again k would be 0. Condition true, yes, enter here. Now see, I value is still 0, k value 0, k value 0, and I value, j value is now, see, j value is now 1. Right? And that's exactly we want to access. Now sum is 0. 0 plus 0, 0 means 0 into 0, 1. 0, 1. Exactly. Now we want to access this row but this column. And we are going to multiply and add. So 0 into 2, but that is 0 only. So that would be stored in sum. Sum is still 0. Now k plus plus, k becomes 1. Condition true. Again enter here. Now 0, 1. And we will access 1, 1. So 0, 1 is 5, 5 into 1, 1, that is 4. This is what? 20. So now 20 would be stored here, right? But k is what? 2, condition true, again enter here. Now k is 2, here k is 2. So we will access 0, 2, 0, 2 means 2. So 20 plus 2 into 2, 1, 2 and 1, that is 5, 10, that is 30. So now sum becomes 30, right? Now k plus plus, k becomes 3, but condition is not true. Exit from the kth loop, and now whatever the value in sum, we are going to initialize that value. We are going to store that value in C of ij. I is 0, but j is 1. So 0, 1, this index, 0th row and 1 column. So here we will store what? 30. So we got this value, second one, 30, right? So now again j plus plus, now j becomes 2, but condition is not true this time, jth condition, right? So exit from this jth loop, and now still we are in ith loop. Now I becomes 1, right? Condition true, again enter here, and again j would be initialized with 0. Obviously condition true, and again the same process would be repeated, right? So now I is 1 now. So we will get this row. And when I becomes 2, you will get this row. And when I becomes 3, condition is not true, exit from the loop. So here we are getting 3 rows and 2 columns only, right? So I hope you got the working of this one, right? It's not confusing, right? So let me show you this thing practically. So now let me show you practically. See, here I have already done this program matrix multiplication.c, because if I'll write the complete coding here, then it would be very lengthy, the video would be very lengthy. So I'll just explain the coding, I'll show you the output. Here I'm using macro, see, hash define n 50. I have just taken a size, macro size 50, and here I am declaring array like what I am not giving any size, I am just writing n, right. So, this is also another way to define, to write, to declare size of an array using macro. That is exactly I want to show here, right. So, that is fine. Now, here I want that user should enter number of rows and columns for these matrix, for first and second matrix, right. So, that is why I am asking here, rather than a static declaration 3 into 3 and 3 into 2 matrix, I will ask from user, right. So, printf enter number of rows and columns for first matrix, and for number of rows and columns for storing the value I am taking what, m and n. So, this you need to take care, m and n, m number of rows for first matrix, n number of columns for first matrix, p number of rows for second matrix, q number of columns for second matrix. This you need to take care. So, address of m and n I am just taking. Now, I am going to enter the first matrix. See, 2 for loops, outer loop would be for number of rows, that is why I am writing here the upper bound is less than m, rather than writing any 3 or 2 or any value, I am writing m. Inner loop would be till n, because n would be number of columns. So, scanf address of a of ij, right. Same second matrix, enter number of rows and columns for second matrix, we are taking variable p and q. Enter second matrix, the loop would be from 0 to p, inner loop would be from 0 to q, and address of a of ij, right. Now, I am printing first and second matrix. So, printf first matrix is, here I am just going to print whatever you have entered in matrix form. So, obviously 2 for loops, outer would be from 0 to m, inner would be from 0 to n, and printf a of ij, that is it, and same we are going to print second matrix. I hope this is clear to you, because we have discussed this thing many times. So, now here also one more thing I am adding, I am going to check if we can multiply the matrix or no. So, what is the condition I have told you? For multiplication, number of columns of first matrix must be equal to number of rows of second matrix, right. If not equal, you cannot multiply. So, here if n number of columns of first matrix, n not equal to p, p is what, number of rows of second matrix. If these are not equal, means you cannot multiply, means it should print you cannot multiply, else we can multiply. So, in else part we will write down the coding of multiplication, this, right. See, so the resultant matrix would be of size m into q. I hope you got why I am saying m into q. M number of rows of first matrix and q number of columns of second matrix. So, the resultant size would be m into q. So, that is why loop would be, outer loop would be from 0 to m, inner loop would be from 0 to q, and in this loop we are initializing sum is equal to 0 and one more loop, that is k, that is responsible for actual accessing the simultaneously the values and multiplying those values and adding, right. So, same I am writing sum plus a of I k into b of k j, and after this k loop I am going to store sum is equal to c of I j, that is it. And here I am printing the multiplication. Printf printing is simple, 2 for loops only, outer loop would be m 0 to m and inner loop would be from 0 to q, right, because you know number of rows and columns, and I am just printing c of I j, right. Now, let me just run this program for you. See, it is asking enter rows and columns of first matrix. So, I am taking 3 and 3, enter first matrix. So, I am entering the value now 0, 5, 2, minus 1, 1, 0, 3, 7 and 5. Now, enter number of rows and columns for second matrix. So, I am taking 3 into 2 matrix. So, enter second matrix, that is 1, 2, 0, 1, 5, 4. See, this is first matrix, right. This is second matrix and this is the multiplication of these matrix. And see, let me just run this again and show you one more output, like if you cannot multiply the matrix, that kind of thing. So, number of rows I am taking 3 and 3 and matrix and number of rows and columns of second matrix I am taking what it is 5 into 4. So, second matrix would be कुछ ज़्यादा ही बड़ी ले ली मैंने, है ना. See, just want to show you this output cannot multiply. Why? Because here number of columns of first matrix is not equal to number of rows of second matrix. Number of columns in first matrix I have entered that is 3, but number of rows in second matrix are I guess 1, 2, 3, 4, 5, and 3 is not equal to 5. So, that is why it is showing we cannot multiply, right. So, maybe this condition you can put where here after just asking enter rows and columns of second matrix. At that only you can check if the condition is true, then only it will ask that enter second matrix, otherwise it will not ask, it will just directly print we cannot multiply these matrix, please enter the correct size, right. So, I hope you got the program now. So, now I will see you in the next video. Till then, bye bye, take care.